Okay, so we are still continuing from the previous one. So here, or in this one, we're having a 2 kg block is released from rest. Always remember that if something is released from rest, if it is released, the initial velocity is 0 at point P 5 meters above the ground. So this point is 5 meters above the ground. It slides down a smooth, frictionless, curved track PQ. So if it is smooth, it means that our frictional force here, it is 0. See the diagram below. Okay, so this is a 2 kg block doing its own things there. So the first question says, state the principle of conservation of mechanical energy in words. So what does this principle say? You actually learned that in grade 10. So this principle says that the total mechanical energy, of an isolated system remains constant, or we can say that it is conserved. So it just depends on how you want to say it, but the total mechanical energy of an isolated system remains constant. So what does that mean? It actually means that EM initial at any point is equal to EM final at any point. So EM, what is that? It is EK plus EP, something like that, as simple as that. So they said use the principle of conservation of mechanical energy to calculate the speed of the box as it reaches point Q. And that should not be difficult as well, because we are from saying the principle. We said that this principle says that EM initial is equal to EM final. So what does that mean? It says EK initial plus EP initial is equal to EK final plus EP final. So what was our EK initially? It was 0. You can see here that the velocity here initially it was 0, which makes our EK 0 at that point, right? So this object slides till it reaches the bottom of the ramp, which we can also see that the potential energy there, it is also 0, because the potential energy of any object that is at the ground level, it is 0. So that's why now our EP at this stage, it is 0. But our EK final, it is not 0. And our EP initial, it is not 0 as well. So what is our EP initial? This is mgh initial equals to half mv squared final. So mgh, our mass is 2, gravitational acceleration 9.8, and our height is 5, equals to half of 2, the final velocity being the one that you're trying to find. So if you multiply this, you can get 98, and half multiplied by 2, it is 1. So this becomes v squared final, and we can do the square roots there. So after doing the square root of that, our final velocity there can become 9.90 meters per second. So it means that our velocity at that point, it is 9.90 meters per second, like that. So let's move on to other questions. Oh, it was just 3 marks. Or sometimes they can ask you relating to this, they can say, so what was the energy conversions that happened there? You can see that energy was transformed from potential energy into kinetic energy, because it was at another height up there to the lowest height, and kinetic energy started at 0 going to its maximum. So it is the transfer from being potential to kinetic energy. right? So the box passes point Q and moves 10 meters on a rough horizontal surface before striking a barrier at R at the speed of 4 meters per second. So this object go to that last point there with the velocity of 4 meters per second, but initially there at Q. So let's have a situation. So at Q, it was having 9.90 meters per second, but at point R, it is now having 4 meters per second. So all the velocities are going in the same direction. So again, here we are told that it is a rough horizontal surface. So rough means that there is frictional force. So between these 2 points, there is frictional force. Use the energy principles to calculate the magnitude of the average frictional force acting on the box as it moves from Q to R. So what did they say? Use energy principles. So there are 3 energy principles that you should know. There is this one that you are from using, which is EM initial is equal to EM final. But this only applies if there are no non-conservative forces. If there's no frictional force, if there's no force applied, we can use this. And the other one is work done by non-conservative force being changing EK plus changing EP. So this one we only use the non-conservative force. If there's frictional, if there's gravitational force, we don't use it. And we also have the work net or the work energy theorem, which says that work net is equal to change in EK. So now between these 3 energy principles, it's obvious that we can use one of these 2. Why are we using one of these 2? Because now we're having frictional force. So it means that this one cannot apply there now. So maybe let's try to use them both to see like how we can find this. But I think the results will be the same because here the object is not moving on a slope, right? So maybe let's start using the work energy theorem. So what does the work energy theorem say? It says that work net is equal to change in EK. And how many forces do we have when this object is moving like that? How many forces do we have parallel to the plane? We only have frictional force. So this, we can say, I know that some you prefer to use the formula with the cos. So if you are good at that, you can use the formula with cos. I prefer not to use it though. Is equals to changing EK. So I prefer to use negative frictional force. So this accommodates the use of cos 180 because cos 180 is just -1. So you can also use it without the cos as long as you know the direction of the force that you're talking about. Here we are talking about frictional force, which always opposes the motion. So it should be a negative force. If it is force applied, it acts in the direction of motion of the object. So it should be a positive force, or you can just use cos 0 because cos 0 just gives you 1. So what is our displacement there? It is 10 being equals to half mv squared final minus half mv squared initial. So this should be -10 of frictional force. So here already we can see that this was already equivalent to 98 there. So we can just take 98 as it is minus half 2 and then multiplied by the final velocity. It is now 4, right, if I'm not mistaken. So 4 squared there, right? So this gives rise to, oh sorry, here I think I made a mistake, vice versa, right? So the final one, it is the one that should be that. So let's just, or maybe let's just do this. Yes, because now remember we are moving from this side from Q to R. So it means that our Q now becomes our initial and our R becomes our final, right? Yes. What's happening? Okay. Yes, you can continue. So our negative 10 frictional force can become our final, which is half 2 multiplied by 4 squared, and then minus the 98 that we are from talking about. So negative 10 of frictional force can become, this can just give us 16 minus 98, which this gives us negative 82. Yes, and you can divide both sides by negative 10, so it means that our frictional force just gives us 8.2 newtons. So this is the magnitude of the frictional force. If they need the direction, obviously this is to the left, right? So let's carry on. Let's see another question. And they say now, just because this thing struck the barrier there, they said the barrier exerts an impulse of 14 newtons per second to the left. So 14 newtons per second to the left simply means that they're saying this is negative 14 newtons per second on the box when the box strikes the barrier. Calculate the change in kinetic energy of the box after striking the barrier. So first thing, because like this question is not clear, they're asking you many questions in one. So you need to understand all the things that they're asking you. At first, they're asking you if you know what is impulse and how you can use impulse, because you know that when this strikes this barrier here, obviously it will change the direction and it will also change the velocity. So we need to know what is that final velocity after striking the barrier. And this is more like a momentum question. So what is impulse? We know that impulse can be given by two things. So impulse, we know that this is F net multiplied by the time, multiplied by the time, or we can also know that impulse is the same thing as changing momentum, right? So the question is, calculate the change in kinetic energy of the box after striking the barrier. So we have to know that here in this case, we need to know what is the final velocity of this object after striking the barrier so that we can calculate the change in kinetic energy. So how do you find the change in kinetic energy? So it means that first you need to find the final velocity. So let's use impulse to our advantage to calculate the change. To calculate the final velocity after striking the barrier, right? So we can say impulse is equals to changing momentum. So impulse is negative 14. So this should be equivalent to mass times velocity final minus mass times velocity initial. So this is the change in momentum, right? So negative 14 becomes 2 VF and a V initial at point Q there. And I always advise that if you're dealing with many points on the diagram, initial velocity doesn't stay initial velocity and final velocity doesn't stay as final velocity. Now it is a matter of respecting the moment that you're having. So now we are dealing with this point here. So striking this should be our initial, and then after striking this should be our final, right? So now it means that our initial velocity there, it should be 4 meters per second, since this block struck this at 4 meters per second, right? So let's see how we can find our impulse, our final velocity. So this should be 2 multiplied by 4. So our negative 14 becomes 2VF minus 8. So we can take 8 that side. So our 2VF becomes negative 14 plus 8 gives us negative 6. So dividing by 2, so our VF becomes negative 3 meters per second, or this simply means 3 meters per second to the left. Whenever you are dealing with all these questions that are mechanical questions, always make sure that you are taking a good care of the direction. When you're dealing with Newton's laws, vertical projectile, momentum, and work energy and power, direction is very, very important. So now let's calculate the change in kinetic energy of the box now. So the change in kinetic energy. So change in EK is equals to half mv squared final minus half mv squared initial. So this, our final velocity, it is 3, or we can say negative 3, because it is going in the opposite direction. So this is 2 multiplied by negative 3 squared minus half, and then 2, and then 4 squared, because when you strike that, it was 4 meters per second. So this gives us 9 minus 16. So our change in EK just becomes negative 7 joules, like that. As simple as that. So again, I will end this video here so that we can continue with the next question. So yes, if you haven't subscribed, please subscribe.